Today's topic, time data acquisition. Here you see the typical startup folder of products where I could immediately launch into the desktop classic, which I'm not going to do. We're going to focus on the Neo interface. So we have a few subfolders here for Neo products. Today we're talking acquisition. So I'm going to go into the Testlab Neo general acquisition, where I've got 4 different products here. I start. And of course, I can launch straight into time data acquisition as one of these products. And time data acquisition, of course, is going to include the Neo desktop. Similar logic to our classic acquisition products like Signature and the classic desktop. So here's the software launching, prompting me for a project database. I'm going to start with a new blank project. So I'll select blank project and create. There's also a choice here if I didn't have a front end hooked up, which I do, but I could work offline. In other words, use a template file that describes the modules in the front end that's already loaded on my system and work using a file instead of an active front end in terms of setting up a project. But I do have a front end, so I'm going to be sure that's off and create a new blank project. So while the software is doing that, we'll have a look at a couple of the differences between the Neo interface and the classic Testlab interface. But to first get in here, the default opening of the Neo interface is this tile view instead of going directly to a desktop page. You can see from the tiles, they're organized in different groups. Here's the instrumentation group, has 7 different tiles associated with it. The default one being channels, which is where we would typically start. But what I wanted to show is some of the other groups here. I could launch into the desktop and view data or go to the help. And what I wanted to focus on in the help was the what's new tile. So if I go to what's new, you get a description here of what's new in our current release. And if we focus on just time data acquisition, which is today's subject, some of the newer features that we'll see during today's presentation, I'll show the Gapless back-to-back measurements that's being animated there. Another procedure that's changed with our bridge modules is the shunting of a quarter bridge to calculate the lead wire resistance is new. Enhancements to the copy and paste of channel information from one channel to another, and support of the 29-bit ODBC CAN interface. Just a couple of the newer features in the 21.1 release. Let me close that, go back to my tile view, and really without further ado, let's have a look at the instrumentation group. And you can see across the bottom here, once I get into the software, I have major tabs across the bottom for those different groups. And then within a group, a sub-tab for, here's the channel setup, my TACO, CAN settings, virtual channels, etc. Different tabs across the bottom of the screen. Here we are in channels group. Let me rearrange my screen here to try and maximize the display information and focus on them Testlab. So here in the channel setup, I have a data grid showing me by default all the possible channels on my devices, subfolders for different devices. You can see in front end, if I drill into the front end choice, you can see the different modules that are available in my front end that's currently connected. So if I wanted to restrict my channel view here to just the channels that are on the first input module, my V8 module, I could select that in the margin and focus on just the 8 channels that are connected to the first module. Or I can go back to front end, see all the channels that are coming from my front end group, which are the different modules. And what you're not seeing in the list here are any virtual channels or CAN bus channels that I'm going to add on, but we're going to get to those a little later. So let's focus first on the front end. And as I jump through these different subfolders, if you will, in the left margin, my view can change, and I can use this up in the ribbon area. I can use this unlink view and link view to pick different views of different columns of attribute information. So what we see here is an on-off checkbox for my, if I widen the column out here, you can see the label for on, a channel ID, a DOF ID, a measured quantity, conditioning. So a limited number of properties. If I highlight a particular channel here, like line number 1, make it obvious with the blue highlight, you can see down the right-hand side, my properties pane, there are a lot more attributes associated with this channel number 1 than what you see in this particular table view. So here I can access all the properties of my channel. And what I want to see here is a subset of the channels. And I can customize this view. For example, I know one of the parameters that's not being shown is what type of module I'm on. If I come down here to my channel identity and expand this list, it tells me that the device I'm on is a V8. Well, I could take this property device and simply drag and drop it up somewhere in my channels list up here, maybe squeeze it in the middle here, and create my own column for a device. So I can see I have a V8 module for the first 8 channels and a second VB83 module for 8 strain conditioning channels, as well as my built-in GPS and my TAX and CAN interface on the Syscon interface module in the front end. So I can customize this table, and of course, once I've made changes, I can go up here to views and say save view as and give it my own name. And then I could go even further to link that view to one of the subfolders, because you can see if I go back to channel devices, my view is linked to the overview and not this particular front end view. So by simply clicking on channel devices, my table view will change again. So that's how the user can control what goes into each view. Of course, I could highlight several channels here and say channel 1 and channel 2. I would like to make those, use some conditioning besides voltage, use ICP. I could make that choice over here in the properties area, or I could change it in the table. Either location will be the same result. If I choose it in the properties pane, you can see immediately the conditioning of those 2 channels changed. Or I could highlight a cell and simply drag it down and change more channels to ICP. Of course, I'd have to turn on the second channel. I have 2 accels I've got hooked up in ICP mode. By default in this mode, they're already going to measure acceleration, so I don't need to change my measured quantity. I might give some thought as to what do I call these channels, so I'll change the point IDs to maybe Excel 1 and Excel 2. And then what sample rate do I want? Now you can see in Neo, if you're not familiar with the Neo interface yet, we've got the sample rates in different groups, data rates. So there's a high rate, a low rate, and a slow rate. By default, all these channels are in the same group, low. They're all currently set to 12.8 kilohertz. If I change the first channel in the low group to, say, 8 kilohertz, notice they all go to 8 kilohertz because I've really just changed the sample rate of the low group, and they're all in the low group. If I introduce another channel, say a quarter bridge channel where I don't want it sampled at 8K, I could put that into, say, the slow group and assign a different sample rate for the slow group. And then all the channels that are in the slow group would have that one sample rate. That's how we control the sample rate across a setup. All right, what else did we want to show in here? Besides channels, retrieving channels. I've got up on the ribbon here at the top of the screen on my home ribbon, because there are some different tabs here for file, home, and help. On the home ribbon, I've got a load channels information. This is a dialog box which allows me to go out and grab from my current project a different section, or grab from a different project the channel setup. So let me show that feature. If I go into this particular project I've set up, has the setup I want to make use of today. It has two sections. I'll use the setup from section 1 and say OK. It will overwrite then all the settings that I've got in that other project. So this can save you some time setting up similar projects, copying the channel setup. Here I've still got my two ICP accelerometers, and what I wanted to illustrate, I've added a quarter bridge strain measurement on the 3rd active channel, and on the 4th active channel I've set it to a full bridge configuration, simulating a load cell measuring force. So in my list over here of measurement quantities, I've made use of the force selection. So my sensitivity here is in millivolts per volt per Newton. The other feature here, so we're going to start with a simple measurement first, and we'll come back and add some more complexity to it. But to get started here, maybe make use of the down at the bottom here, I've got an arm button where I can arm the front end and basically slide over to the right here. I see some signal levels and perhaps some data. Look at the right piece of property information. Here's some channel statistics on one of the channels. If I select my first accelerometer channel, these are the statistics on the Excel. And if I tap on my Excel, a couple of things, you can see the numbers changing. But more significantly, I wanted to focus on the signal level display to give you some idea of, are we overloading the channel? Is there a signal there? I can do that here from the channel setup as opposed to going to the measure sheet to do this troubleshooting. Another thing I can do is disconnect one of my bridge channels, and you can see I get a message here with the red X telling me there's a problem on channel number 9. If I park the mouse on top of the red X, I get a tooltip explaining it's an open bridge. I've disconnected the power supply out of the chain, plug it back in again, and the red X clears up. Things like error messages will keep displaying in the bottom until some other message comes up. So if you look in the very bottom left corner of my display, I do have the last message showing channel 9 bridge open. If I pull up the list of messages, I can see all the previous messages that have gone by, and I can always clear the message history to start over again. So there is no pull-up of previous messages. So I can do some channel troubleshooting by arming in the channel setup. The other thing I wanted to illustrate before we get off of this is the read TEDs. So by clicking read TEDs, any of the ICP transducers that are TEDs enabled will fill up with information, and you can see that here in the blue cells. These are cells that have now changed based on the information it's read from the TEDs interface embedded in the accelerometer. And of course, I have more parameters visible in my properties pane on the right, showing what are all those changes. If I hit the accept button, it's going to save those changes into my current settings. And the other thing it's going to do is potentially change something. And here I have a red X complaining the property DOF ID is not changed. Okay, so it hasn't relabeled my Excel 1, Excel 2. But what I wanted to illustrate, continue. Okay. So it didn't change the DOF ID. That's fine. I didn't have that programmed in the accelerometer anyway. So here you can see over here on the right, the channel sensitivity for those two transducers has been updated to the TEDS value that came off the transducer. So not quite 100 millivolts per G. Before we go on, I'm going to save the project. Goes out to my working folder here. I'm going to go down into the subfolder for today's webinar, time data acquisition, and give it a new name, webinar.lms for the project database, and move on to, what else did I want to illustrate here? Calibration. So before we get to measurement, I'm going to switch from the instrumentation tab at the bottom here to the calibration tab, and then I can see 4 different sub-tabs here for calibration. Park here on the first one, AC calibration for my accelerometers. So you can see up at the top here, the table of active channels. I had 4 channels turned on, so I only see 4 channels. 2 of them are selected because the other 2 bridge channels typically are not used for AC calibration. Over on the right, in the properties pane here, I have some information about the calibrator. What I want to show is if I change my calibration unit from G's acceleration to pressure, pascals, you can see a list of calibrator names has changed. So I can grab a particular calibrator for my microphone, which I haven't got set up, of course, and hit apply, and you can see it's retrieved from a file that the user can customize all the necessary reference values for a particular calibrator. So here's a microphone calibration setting at 1000 Hertz. Of course, I don't have a microphone, so if I go back to G's acceleration and pick a calibrator here, apply, here's my 1G RMS calibration at a fairly low frequency for this older calibrator. And what I see is a red square telling me there's a problem with the cutoff here. It's got a built-in cutoff frequency of 80 Hertz to avoid the noise, a high-pass filter. I'm going to reset this to 65 Hertz because my calibration is going to occur at 80 Hertz with this calibrator. So I want to take care of that red message. And observe also that in terms of channels that are available, because I've picked an acceleration unit to calibrate, all the accelerometers in my channel setup are selected. Well, I'm going to do one at a time. Let me just use channel number 2, ensure it's on the calibrator, fire up the calibrator, and focus on channel 2 here. I'll hit start in the bottom, and then you'll see the typical displays here showing me a frequency spectra for channel 2, as well as a time recording for channel 2. So there's my sine wave at 79.8 Hertz. It's finished detecting the channel and calibrating, and it's calculated a new sensitivity. So if you recall from the TEDS reading back on the instrumentation tab, we had pulled in a sensitivity of 97.7 millivolts per G, and now we've just calculated a sensitivity of 101 millivolts per G. If I like that sensitivity, I would hit apply. If I didn't want to keep it, I could restart the calibration. But if I hit apply, of course, now we've updated the sensitivity on our second accelerometer to that new value. And then I could continue on. In the interest of time, of course, the other types of calibration that we have available, DC calibration, where I could come in, say, my load cell, enter a 3-point calibration, just a 2-point, however many points you want to add to this table, and you could fit a linear line to these cal points and come away with a sensitivity and offset for another transducer. In addition, I have offset type calibrations for my strain gauges. So the accels aren't automatically checked for balancing, but my bridge module channels are automatically checked. So my strain gauge and load cell, I can perform an offset calibration and balance those 2 channels. Those are the types of functionality that we have available in calibration. Save my changes to the project and then go have a look at the measurement tab. So across the bottom, going to the measure, we still have offset checks, shunt checks, ranging, measure, and validate. So I've come to the default measure screen where I've now changed my list here to show what's available in my active run. So right now we're looking at the setup. I've got 4 channels set up, 2 accels, a load cell, and a strain gauge, quarter bridge strain gauge. And the data screen display is set up to show me all the functions I have available for my first channel, Accel 1. I have my different properties over on the right when I'm in the setup view here. And if we want to focus on some of the setup properties, here I have my measurement annotation. I have a set of attributes. We deliver a file with the system that has a sample set of attributes for you. So for any particular run, the user can provide a comment, provide information about where the measurement was taken, say the proving ground, maybe identify the vehicle. This is A, B, C, D, 1, 2, 3, 4. That sort of information is the attributes that will be saved with this acquisition. And if you want to prompt the user to enter those attributes, you can make use of this setting over here. I'll show this. The run annotation prompt, if I select after measurement, when our measurement is done, the dialog box will pop up, allowing me to edit the run annotation information. We'll do our first measurement with the default settings here, just a manual start and a manual stop. And what I wanted to illustrate was when I arm the system now, data starts flowing into the displays. By default, I've got a time history display here of 2 seconds. I can change that down here in the properties, bump up that time if I want more time displayed, as well as some statistic and hardware information and the channel levels. Tap away on the Excel here, you can see my impacts on the tabletop as well as the level I'm achieving in the channel overview. All right, if I go ahead and do a start measurement, we'll just collect data on these 4 channels. I'll tap on the Excel, and I want it to tap hard enough to generate an overload on the Excel. I also wanted to generate a problem with my bridge conditioning module by unplugging that power supply. And then I will manually stop the measurement. So you can see at the end of the measurement, the annotation information has jumped up in my face here, and I can now change, set an appropriate to comment on what happened during that measurement. Close, and we're ready to start another measurement. If I disarm the system and want to have a look at that previous measurement, what I wanted to show was drilling into the project, into section 1. I've now created a run 1. And in run 1, again, if I look at all the information here, I could again look at an individual channel. Here's my Excel for the entire measurement. It happened to be 21 seconds. Here's statistics and hardware information. If I focus on just the hardware information for all 4 channels, I can get that by clicking in the pivot table grid here on the left and say, show me all the hardware checks for all 4 channels. Here's the summary I wanted to focus on. You can see for my Excel, we experienced an overload. You can still see that in the frozen display of channel overview at the bottom there, as well as a problem on my bridge channel, strain 1. Again, a supply open message there caused the error. So you can get a summary of instrumentation problems during the measurement here in the hardware checks. I just wanted to look at the time data that I've collected for all 4 channels. You can see I can see that in this strip chart-like display by selecting all 4 time functions. All right, let's perform another measurement where we're going to change things up a little. Instead of being manual, let's do a duration. Make it a 12-second measurement instead of the default 10 seconds. And a base name. In the base names here, I can provide different run names instead of the default run. I can upfront give it a range of surfaces. Maybe I'm doing some driving on different road surfaces, and I want the run names to reflect those surfaces. So let me pre-populate run names, Belgian blocks, space 1, add that, or something else like concrete, 80 kilometers per hour. Those type of information, those are what I'm going to build my run names on. So if I say OK to that, then my pull down list here can say, OK, I want to do an asphalt run. If I was to select a run that already had an increment number on the end, like Belgian blocks, I intentionally put a space 1 at the end, and the next run is automatically going to become Belgian blocks 2. It's just going to increment a number on the end. And let's see, once I've made those settings, my previous measurement, I accepted this setting, but we have the flexibility up here in the ribbon to modify the layout and get rid of the information on the right-hand side, all the properties and control parameters. I can get rid of that by going to the measure layout, where those are moved off to the right margin, and we can focus more on just the displays for the actual measurement. So here I will arm the system. I've already got my run down here next to the right of the arm. You can see it's going to be Belgian block space 1. And by hitting start, oh, before I hit start, I just realized my displays aren't updating because I'm busy looking at the first run. I need to be looking at the active run. So here in the left margin, I'm going to highlight active run and show 4 time displays from the active run. So here I've armed already. I should be seeing live data coming in. I happen to be looking at an old run, my first run. So here I will hit the start, impact a couple of transducers, impact, or basically move some of my other load cells, strain gauge, and there my 12 seconds has elapsed. I haven't pointed it out, but in the lower right corner here, you can see there was a timer for how long the acquisition was going on for, and we reached our 12-second stop time. So the measurement has stopped, and again, the annotation has popped up in my face that I'm going to go and add a new comment or change one of the conditions and close it. All right, so we've done 2 acquisitions. What I wanted to show next, if I get back to my setup view, we want to do multiple acquisitions back to back. Gapless acquisition, we were pointing that out in the what's new information for this release. I'm going to disarm the system so I can make some changes to my settings here. Let's remove the run annotation popping up at the end of the measurement. It'll be up to me to manually modify the run attributes. Leave it on 12 seconds, but let's add 2 runs for multiple runs. 2 12-second runs, back to back. And in the history size, let's show more time, maybe 5 seconds worth of history data. And let's switch to, say, concrete, different run name. All right, let me go back to the measure display. Arm the system here because I'm on active run. I see the data live updating in the display, fills the 5-second display, and then scrolls by showing 5-second duration. Here I'll do a start. Again, just make a few things move for interest on the screen. At the end of the 12 seconds, I wanted to have something to show on the load cell. And immediately it's gone into a second acquisition. Didn't give me a chance to start. So it started automatically a second acquisition. So here I will disarm. And what I want to illustrate here now, when I look at a particular section, I now have several runs. First of the last 2 is the concrete 80 kilometers, and because I didn't obviously have a chance to change the name, it's just incremented the number for the second one. And now it's showing me all 4 runs in my data display here. Normally you can, of course, look at one at a time, but what I want to illustrate is if I look at multiple runs and pick a view here that includes the run name, which is what we're looking at. Here I can see from my concrete 80, if I look at my load cell time history, and from the second concrete 80, use the control key to look at both load cells. So here are 2 different runs showing the same channel 10 load cell. And what I want to illustrate here by doing this is changing the x-axis here from just duration to absolute time. So because we had a recorder giving me a potential GPS signal. It's also got an absolute time signal. So now I can see on an absolute time scale, the red load cell being my third run, immediately followed by the fourth. And if I go to my display tab at the top, onto this ribbon here is a stack overlay. I can toggle back and forth my display to overlay or stack the channels. So what I wanted to illustrate here was if I zoom in to the junction here between these two displays, you can see that we've got the second run starting one data sample away from when the first run ended. So essentially gapless back-to-back data acquisitions between those runs. All right, let's go back and add some more interest to our channel setup. Let me jump back to instrumentation. Now, if I'm going to make changes to my instrumentation, good practice would be to create another section in my project. So up here on the home ribbon, I have the ability to create a new section, section 2, or give it whatever name I want, and it'll take over all the settings from my current section 1. So I've got the same channel setup that I've just finished, but of course, if I wanted to go back to make changes in section 2, I could always go back to section 1 and not have those changes follow me around if I wanted to repeat a particular setup. So in this section, I'm going to add some more channels of interest. I wanted to illustrate with some CAN channels. Here on the CAN tab of instrumentation, CAN setup. Up on the ribbon here, I've got a dedicated Add CAN configuration. This allows me to go out and select a DBC file to describe my CAN bus. Pick an example file here that has quite a few channels. And to keep things simpler in the displays, I'm going to grab just the signal name instead of the full name. Keep the name a little shorter. And now it will read the DBC file and show me all the channels that are available on that bus in the lower display. And you can see from the vertical scroll bar here, there are about 1,000 channels in this DBC file. So an awful lot to look at to make it usable. What I would propose is on the columns here, we have some filtering available. Say on the unit column, I know I want to collect, say, a vehicle speed and maybe an engine RPM. Well, if I just pull down the CAN unit column, here you can see all the different units. Well, I don't want them all, so I'm going to select them off and then just pick and choose a couple. And here I want vehicle speed, so kilometers per hour or kph, both of those are vehicle speed, as well as say maybe RPM, lowercase RPM, uppercase RPM. So those 4 different units makes the list of CAN channels much more manageable to choose from. So here you can see, okay, maybe I want this vehicle speed here, and maybe some particular engine RPM here. Much more manageable list to pick my CAN channels from. So I've selected a couple of channels from that DBC file. If I finish the upper portion here and say, yes, I want to make use of the CAN input on my front end. I want to use a configuration. Well, the one that we just went through in the bottom is this HS1 CAN. Baud rate, 500,000 by default. And passive, just to show you the possible choices. So with those settings complete, my channels selected in the configuration, I hit apply, and those message line is saying the CAN configuration is being applied to my current channel list. So by going back to the channels, I should see the addition of 2 CAN channels to this list when I'm looking at channel devices. Here it's updating. And here I can see the 2 CAN channels with the shortened signal names here. Vehicle brake and engine out. I could also see that information in the subfolder, CAN bus channels. What am I thinking? Yes, 2 CAN bus channels. Oh, let me, fairly straightforward. Of course, GPS is available if I have my GPS antenna hooked up. and outdoors to get satellite, but for example, the user GPS speed as a channel to be collected as well. Let's focus on the TAC. I have 2 TAC inputs on my system controller module. I'll take just the first one, and you can see from the conditioning choices here, I have an analog pulse or an analog pulse width modulation signal, or both of those with ICP powering to the TAC transducer, as well as digital pulse, like TTL type pulse information, giving me a digital TAC stream. Let's focus on just the first one here, the analog pulse. Then I want to go to the next subfolder, tachoscope, to set up the rest of the TAC. I could, of course, focus on the parameters on the right-hand side for the TAC, all properties, but I want to use the user interface here for the dedicated TAC setup. The other thing I want to show, instead of just stepping through this, is a feature that we have as part of the help. On this particular worksheet, tachoscope, in the lower right corner is a guide me that I've parked the mouse on top of. This orange or yellow guide me button will bring up a small dialog box explaining the functionality of this workbook, summarizing it. And what I really want to focus on is at the bottom here, we have a step-by-step procedure for you that you can follow as a new user to get familiar with the user interface. If I hit start, this procedure is going to guide me in all the different steps I'd need to cover this particular application on the tachoscope. So here I see step 1 of 5. It's telling me to check on the TAC next to the sensor I want to set up. Well, I want to set up TAC 1, so I check it on under select, and then I go to the next button. Step 2, arm the front end. Okay, and go next. Step 3, move the cursor in the displays to read out the crossing level. Okay, so here you can see a TAC going by. It's I'm playing a wave file into the front end from another PC, and it's a fairly low speed TAC here at the beginning of the wave file, so I don't see too many pulses. So the first thing I'm going to do is deviate from the script here of guide me and increase my scope time window from 10 milliseconds to 100 milliseconds, so I get to see some more realistic pulses, both at low speed now and at the higher speed. And what I want to illustrate also, in addition to the pulse train, here we are in the wave file cycling back. Here's my pulses back. As the RPM increases, what I want to illustrate is the RPM value being calculated on the bottom. Okay, so here's a 0 to 500,000 RPM. Well, I get these spikes in here. Why am I getting these spikes? Because the pulse detection level is at 0 volts by default. And you can see from my cursor here at 0, that's not a good area to be counting the time between the pulses because of these areas that aren't very clearly defined. And you can see they get rather noisy. Here's some more erratic RPM pulses. So what it's telling you to do in the guide me is to find a clean area of the TAC. So I'm going to move this around visually to find, say here at about 3.5 volts, somewhere in the middle here, if I don't get these weird multiple crossings. Okay. Now it's still being calculated at 0 volt just because I've moved the cursor. This lower display hasn't really changed yet. That's the next step. I go next. It's telling me, okay, now you update the detection level in the table. So instead of 0 volts, I want to use 0.35 volts. And then next, we would disarm, but what you can see right away is how it's cleaned up the RPM trace in the bottom display. So here we have our wave file stopping for a few seconds and then starting up again, running along here at about 2000 RPM, okay, and then ramping up. Well, I know it's not idling at 2000 RPM. If I disarm, close the guide me, that's the 5th and final step, and I know I have 3 pulses per rev. I'm going to have to go over here to the properties and update that. That's not part of the 5-step guide me. is the pulses per rev. So some more advanced parameters, if you will, on the right-hand side here under properties. It's going to be 3 pulses per rev, and to get a cleaner looking tach, I'm going to skip 2 pulses. So I'm effectively only using 1 pulse per rev. So if I arm the system now, view the tach, here it is idling just above 600 RPM, and now we're ramping up in speed. So this wave file will replay, takes about 30 seconds here to go all the way to the max RPM of just under 4,000 RPM. We'll see on the display here, and then it'll change direction and come down quickly, and then replay the file. So there it has peaked just below 4,000 RPM, and the RPM's coming back down. Fairly clean looking RPM trace now. So there's my tachoscope setup. Let me go now back to measure. I'm in the measure setup. I'm going to get the setup parameters back. Right-hand side, I'm going to make some changes here to the start trigger. Yes, we've set up the tach, so now I'm not going to use manual start and stop or duration. We're going to base it on the tach channel. So we're going to use a start trigger type of channel, and then pick which channel out of all my available channels that we're measuring. There's a tacho 1. I took the default name, and we're going to start the measurement at 1,000 RPM after the idle phase. In the up direction, hysteresis of, let's maybe put in a non-zero value, 5 RPM, and a pre-start time, let's do 2 seconds. We're going to keep some data ahead of the 1,000 RPM. And similarly for our stop condition, we're going to base that on the tach as well. And we're going to stop the acquisition at 3,800 RPM, just below the 4,000. Again, hysteresis, non-zero value of 5 RPM, and we'll also add 2 seconds on to the post-stop time. So we'll keep 2 seconds of data after the stop condition. Here we can introduce just the default run name, or I can add a run up space 1. Make use of that. Go back to single measurement, not back to back, and put the run into the input basket. That's another interesting feature. So I'm going to load up the input basket with my data at the end. All right, we're going to make use of the active run again, not the previous runs in section 1. And let me arm the front end. And here's my tacho. I'm going to start. Look at some data channels. Again, move things around a little bit. And the tach information, again, I didn't forget to point it out, but over in the lower right here, you can see it updating again now, ready for another measurement. There's my actual RPM, and then what is the target RPM. But I turned off the multiple runs, so it's not automatically launching into the next run. I would have to hit start to do another acquisition. That wasn't my intention. My intention was to show you the data from the first run. So let me go back to disarm. So from my run up 1, I'm going to go to the validate sheet here. And here I can drill into my project with my data selection. Not in section 1, but in section 2. I have this one run up. And here's a list. Obviously, the channel list is increased in size. If I focus again on just some of the time channels, not all of them, let me use the control key to select a few of these that make sense. All right, let's just take those and let me get a cursor on here and change the axes here from my GPS absolute time to just relative time. So basically 0 to 25 seconds. Lost my cursor, turn the cursor on. Select the RPM trace so I can see the data here. So if my last data point is up here at 25.44 seconds, I'm going to back up 2 seconds worth to 23.44, close enough. And you can see my RPM at that point is just about to pass through the 3,800 RPM. That was our end point of the run-up, but we asked it to keep 2 additional seconds. Okay, so that gets appended on after the 3,800 RPM. And if I move the cursor here to 2 seconds, at 2 seconds, this is where we're passing through exactly 1,000 RPM because I also asked for 2 seconds pre-start. So that's the idea of pre-start and post-stop time added to the measurement. I think the last point that I'll make here is that, of course, we're focused on time data acquisition. So a lot of customers coming from classic test lab will be more familiar with signature acquisition, where we do a lot of calculations as we're acquiring the data. Here, the philosophy is quite different. We've designed the tools to make it more straightforward for a user to collect good quality time data. Okay, we have some checks to help identify poor data, obviously the visualization, but also the hardware checks and statistics. But we aren't generating a lot of processed results or any processed results. To do processing, to come away with frequency spectra or order cuts, that will be an additional step in processing. So I have taken this data and added it to the input basket. So normally the user would then step over to the processing section, focusing on the input basket here, which is what we're loading up here. The input basket containing my last run. All the channels are selected. And we design a process. Now the user can design a process or open an existing process, but the concept here is you take your input data, and if you want to calculate a frequency spectra, you just calculate a spectral map after that input data. You can go on from that and calculate, some order sections, for example. So we have available in these different method libraries, we have a library for interactive analysis, for signature analysis, synchronous resampling, order analysis available. You can design a process and then crunch through that particular process. Just to illustrate that, if I go to the process ribbon, I can not use this simple process, but open up one that's been created before. So I could have had a colleague create one and share the file with me. Okay, so these processes can be designed and then added to other systems. And then at the end of the acquisition from the input basket, you can then run through this process. This particular process will split the load channels from the dynamic channels, do a spectral map, calculate some order sections. The properties of an individual process are over here in the properties area. And if I go ahead and look at the active analysis, so after the run, you can see it's up to me to accept the result or reject the result. Well, before I do that, I'm going to go look at the result, and it's in this active analysis folder where I can then see, okay, for my accelerometer here, I've got a spectral map available. You can see where I was tapping away on the Excel, some order levels relative to the TAC, and a time history. Or I could focus on just the spectral map and say the order sections. For instance, I don't have to look at the time history. So you can customize the displays. But here, if I accept the data, it will write the spectral information into a new run in my current project under section 2. So we have our acquisition run and our processed results. So that's where I would like to end today's webinar. Thank you.